For the recording, I do apologise, we're now on slide number 6. Talked about how to find, we're talking about just now how to find the standard deviation. We'll go back a couple of slides. N being the total number of samples, 22. Fi is the measurement for the individual specimen. We'll look at specimen 13 for just now. And variance, essentially the difference between 13th Fi and the average. So we'll get the variance from this equation here. Oh, sorry. The standard deviation. Now we're doing the variance for every single one of them, and we're adding this is sum of, so it's the sum of all of them. So if we do the 13, we have to do the 14, 15, 16, and it's the sum of all of that sum divided by n gives you the variance for the whole lot. And all you're doing is you're just square rooting it to get just the standard deviation. Really straightforward. However, doing it by hand is a lot of work. By Excel makes it much easier. We'll go through doing this next week in the Microsoft Excel tutorial. So we will do a sample of how to do something like this. In here. This is quite interesting. A small value of standard deviation means a small variation in material properties. A higher standard quality of the timber stack. I.e., if I've got a timber stack and these samples are some really low and some really high, I would say that quality of the wood is it's not a good fit, is it? You would really want if you're a timber merchant, you want to buy wood that's consistent, dependable and reliable. So you don't want to have a standard deviation that's bonkers. Example here, we can see the standard deviation for the top set is 2.2. What is the unit of standard deviation? Can anyone tell me? Come on. What? I was hoping you would do that, right? And I can tease you a wee bit. No, the unit of standard deviation is depending upon the variable that you're referring to. If it's millimeters, then my standard deviation will be millimeters. I'll give you an example of what I mean. I'll do a bit of a side step for a second. Here we are. And I know for a fact you've all seen what I'm about to do now. I know you have. I'll show you it anyway. Perfect. Well, do you know how we talk about tolerance? You ever seen somebody say, build me a shelf, and the tolerance is, and they'll do something like this. 15 millimeters, sorry, no, let me get this right. Say 2 meters, 800 plus minus 10. Anyone ever seen that before? Perfect. Right, so you've seen that before. We'll come back to this page in just a minute or two. when we've got an average value of 15.2, right? I haven't read this time. 15.2 plus or minus, sorry, 2.25, I think it was, newtons per millimeter square. So essentially what I've done there is, that's the average whatever the data set is, that's the average number. And then my standard deviation is plus or minus my standard deviation. So the unit is always going to be the same unit as the variable that we're referring to. So it could be millimeters, newton per millimeter, whatever it happens to be. So it's a trick question, do apologise. But you understand now, yeah? And that's where we use standard deviation. Make sense? Perfect. Let's go back to this then. So the stack for this wood here would be a much better quality of stack than what we would get here, because the standard deviation is 11.14. That means some are slightly higher and some plus that, some are slightly higher than that still, to be honest. That's just the standard deviation. And then some are going to be that minus that and a little bit lower as well. So hence why it's quite evident this is not as good a quality of stack as that one. Make sense? So, right, I'm conscious of what I was saying before. I'm going to go on a side tangent again. I'm sorry I do this quite a lot. But I want to make sure you fully understand what we're talking about. When we're buying structural timber, you want to buy it with everything sprayed, all the markings sprayed on it, or you shouldn't be buying it. Are you okay? Are you suffering with the heat?
Yeah, no, just fell asleep, sorry.
Oh, I think the heat's getting me as well, and the sleep. 1-year-old in the house.
No.
Right. However, this is not the case for our structural timber in Scotland. However, in England, when you've got sawmills that are doing hardwood sawmills, their wood predominantly isn't strength graded the way how we would do it up here, because their sawmills are a lot smaller. It's not as big a market down there. Or their sawmills might be using hardwood, and they might not have the data sets to do strength class grading. What they'll do is visual grading is what they'll do, and that's a very specialised job. You have to be trained to do it, but then it's difficult to do it accurately, especially if you try to do large bundles of wood. So it's quite often not possible to test the entire lot of material. So now we're getting into the niche market, okay? Now I've done literally this before. I've taken a student intern into the forest, spent a whole day grading a whole batch of wood that was taken out of that forest, processed with a wood miser. Wood miser is like a big massive bandsaw essentially, and put into a kiln to dry it all down for like 3 weeks. That then came out, and Hugo and I strength graded about 400 bits of wood, but we only strength graded about 400. We didn't strength grade 4,000. Yeah, that's all we could do. Yeah, so all we could do in one day. So we strength graded those, but we had an understanding of the wood from that forest, and it gave us enough. So we have done what they might do in England quite a lot, but we've done that intentionally for a purpose. However, the larger the sample size, the better. If I only sample 50 rather than 400, then my sample size is not going to be good enough. My slides are on auto time. Does anyone know how to take auto time off? I'll just have to go with it.
To your animation.
Animations.
Just check and see.
No, there's a way to turn them all off, I know there is, but see for just now? Just now it'll be fine.
If you go to transitions and then go on the far right a third time.
Animations.
No, transitions.
Transmissions.
The next
Animations.
one, yeah. Right, or am I?
Oh. It's off. Just go with it. Oh no. Right, okay, I'll try and relax. When we're sampling our data or the wood, we want to select the materials, we want to go sampling randomly. What we don't want to do is go into a large wood pile and go, I'll pick out this piece, that piece, and that piece because they look good, to try and massage your data. Don't do that. It should be random. However, what we'll be doing what's called a small clear. We're doing small clears. So there's two things here. We're testing like what we do down at Seven Hills, which I hope will take you down. We're doing at Seven Hills, we're testing full members with all the defects. So we're testing members with full defects, and so that should be totally at random. There should be no pre-selection whatsoever. What we'll be doing in the lab, in your lab downstairs, we'll be using small clears. Small clears are the total opposite. We have intentionally selected the wood because they are perfect. There's no knots, no wane, no cupping. It should be perfect. This is weird because it's been broken. That's why it's a funny shape. So that's why it looks weird, but it's been broken already. Right, so if the material property is estimated from a sample, blah 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 blah, then the N has an effect. Okay, so we're moving on to your actual coursework now. Okay, we're okay for time. We're going to finish early today, I think. So that'll be good. See, before we do this, let's have a chat about wood. I think some of you might have heard this before. If you have, I do apologise. In this module, we're looking at 3 types of tests. The first one is compression like that, the second one is that, and the third one is 4-point bending. Let me just magnify this up a little bit, and let's use the perfect model for timber that ever exists, apart from its plastic straws. Plastic or straws is actually a good representation of what timber is. Now you saw on my middle page, on the first slide, one of my colleagues from Seven Hills has put a slither of wood under a microscope, and he's given me that beautiful image. What you see is essentially that. It's the end grain of the wood, and it literally is just straws. All that it is. And what holds the straws together is a poly bag, plastic bag. It's actually called a lignin. You ever heard of a lignin before? A lignin is what makes the wood have a woody part to it. It holds together all the cells. So for each straw is one cell, yeah, essentially a cell. If each straw is a cell, essentially, the lignin glues it all together. Make sense? Now, my straws are strong this way, you'd agree. quite strong because they're held together with my lignin. Quite strong. However, if I rotate them round and I squeeze them, there's a lot of give. Okay? So in BSEN 338, there's a table for strength class of timber. You've seen it before this morning. You'll get values for the strength class grades of material, right, which your batch should on average meet. And it'll give you values for the strength that way and the strength that way. For normal softwood, you'll find that it's roughly about 8 times stronger this way than it is that way. That's not the full story though, is it? Because that would be too easy, that would be just game over, module done, everyone passes. It's not the full story. But yes, that's significantly stronger than that. Right. And I do say that holds out as my best model that I can think of to talk about wood.
I'm assuming that wouldn't hold true for bending, though. I'm assuming it wouldn't hold true for bending.
What a bit louder, sorry?
Sorry, I'm saying I'm assuming that wouldn't hold true for bending.
Well, for bending, we're going to want our straws to go that way.
Yeah.
You wouldn't stack it all like this.
That's what I say, it's like, you could just like do lots of slices and lay them out there.
And have zero, and have very little strength whatsoever. So we want our bending perpendicular, don't we? We want our bending this way. It's a good point. Thank you. Right. So, all I'm saying here in this slide, you need to read this. Not the full thing, the parts that are relevant for you. So for today, we're looking at 2 material properties will be assessed or tested. Modulus of elasticity and material strength. That's what we'll calculate out of the first test we'll have. So the size of our samples is important. They have to align with. And I'm not going to give you all the answers. You need to do some reading yourself. But my material sizes are controlled by the test method within BSEN 408. Find me that you think the page number would be, and you can keep that as well if you want. For test procedure for this one, I'll not use the wording, probably come from the slides, but just read through it whilst I'm talking. So, my sample, my length, my breadth and my height. For this one here, I'm going to have my breadth and my height the exact same, or as near as possible, because we'll have to use a planer or a sander to get it to make these. It won't be just as, it's not as easy as you think. If we're trying to do it commercially. If we're doing it commercially, we would have to do it precisely and get calipers out, and there will be a degree of accuracy would have to be followed. Which page numbers, have you found it?
We're doing it, doesn't it? It's like
It's doing parallel to grain. Parallel to grain compression. So,
high five.
page 35, right? Just keep hold of that there, that's now yours. You'll want it, trust me, you'll want it. So we're going to calculate the compressive strength parallel to grain, or FC0. And the 0 indicates the direction of force to the grain. So when we do it this way here, that would be 90. Make sense? Well, we're not going to test the tensile, but in the code, it will tell you how to test for the tensile force as well. We will be checking for the compressive strength orthogonal to grain or perpendicular to grain. So we can see that's now changed to FC990. Again, we won't be doing that in the lab downstairs. How many directions orthogonal to the grain are there? Question to use. I'm brave enough to answer. There's the grain. Okay. 2. Right. Another trick question, isn't it? Because if you think you're right, because that would be 1, that would be 2. However, because it's a natural material, it's a tree. Part of a tree is infinite. It's just so when we're looking at material like this, it's hard to tell. You know, before we talked about how you cut, well, how you cut a piece of wood. Okay, that's a trunk of a tree. It's very small branch. How you chop up that, what you would get. Can you see the rings there? Can you see the rings? Depending upon how you cut the board, so the answer is many. It's many different directions. It's too easy to just say 2. So it's a trick question. So the answer is infinity, right? So wood is naturally it's natural material, so it is going to be different in every direction. Especially this one here, you can see that. That's quite nice. But there's different types of how you would cut the boards, and it would then give you more stable material. So when you're looking at furniture, like fine hardwood furniture, there's a certain way of chopping up the board that cabinet makers or furniture makers will pay an awful lot more money for. Because if your log's only like that, or whatever diameter, you're only going to get a certain amount of it cut the way how they want it. And that's for dimensional stability. So they'll pay more for forgotten the word now. The word's not out of my head, but I'll tell you later on. But they'll pay an awful lot more money for certain cuts of wood just because of it's desirable. The answer is infinity. Right. So what we'll be testing on lab 1, it'll be that one there. That's just the strength. Now we want the MOE, modulus of elasticity. In the same test, we'll be able to calculate the MOE as well. And that's going to be derived as this. There's other things we could test for. Tensile, MOE, parallel to grain, perpendicular to grain. We will be testing that on our second one, not the first one. Again, we won't be doing that downstairs. During the practical session, we will only be concentrating on these here as I've stated before. Test, and the second one, then plus the 4-point bending test. But we'll talk about that another day or next week. Right. So our sample should be, the length should be 6 times the breadth, and my height for this test should be the same as my breadth. Okay. And what we're going to get is a compressive strength given by this equation. Right. I think you answered this question before. I was drawing on the board. And we talked about how to find the F max. You've got a data set. For this one here, it's really easy. It's really easy. Or let me rephrase that. It should be really easy. For softwood, it definitely will be. You will get a graph that looks something like this. It'll go up here, then it will lose some strength, and then it will fall off a cliff face. Okay? That's what we should get if it's a softwood. If it's a hardwood like this one here, this didn't behave quite like that. How it behaved is this part here was elongated, it was still going down. It never got to a cliff face because we stopped the test before we eventually broke it. But it had already failed, the F max was already reached. It's never going to get any stronger, but the test never fell off a cliff. The softwood, it will fall off a cliff. It will just break fairly quickly after the Fmax is reached. So, but it's easy. All you have to do, test it this way, is literally Fmax, way back there. In Microsoft Excel, it just equals max, open brackets, cell range, close brackets, end of, and you've found the Fmax. You then want to find where that Fmax appears within the data set. There's other tools I can show you later on how to find where that is in the data set. And for yourself, if you're ever doing anything like this, we've got professional sheets made up by Wojtek and Mark Millen. So they're commercial. They give you, put the data in, it gives you the full report. So it can give you access to all of those if you want. But not you guys, you have to do it yourself. So that's our Fmax, quite easy. But our compressive strength is given by this equation here. And all it is Fmax divided by breadth times height, or area of, right? So all that it is essentially that area there, Fmax, and that gives us the strength. That's ultimate limit state strength. My throat's starting to go. MOE, or the modulus of elasticity, is an exact same test, or it will be the same data we'll have. It's exactly the same test, so the sizes should be exactly the same. This is the equation that we'll be using. Right. Don't get scared, it's actually quite easy. I would write this down, I'd heavily write it down. And we'll discuss what W1 and W2 are in just a second. Depending upon our time, I'll either show you how to do it in Excel today. We started at 9:30, yeah? Write this down. Draw the graph as well. Draw that graph with that equation for your notes. I know you've got the slides anyway, but it's good to write things down, and so you've got a mental picture in your head of what's happening. So far I've not told you how to find these 2 points. I've only told you how to find this one. And it's not cut and dry. It's not cut and dry how we do it. We all good? I was trying. Okay, so when we do this, it just means approximately. So all that it means, approximately. So F1 is 10%. F1 is 10% of the Fmax. This is what I would do if I were you. I would start off with F1 equals 10% of Fmax, and F2 equals 40% of Fmax. Start off at that. Once we've done that, we then want to figure out I want to figure out if that's correct or not. The expression comes from then. I'll tell you what, we'll do it in Excel just now on the board. I'll do one from last year's data. That's what I'll do. your data will be very different. Now I'll do one from 2 years ago is what I'll do. I'll do their data because theirs is softwood. Yours is likely to be softwood, I think. Depending on what we've got downstairs in Merchiston. Because I'm not going to go back to Seven Hills, get some hardwood today. I'm not doing that today. Where this comes from is a stress-strain relationship. E equals stress over strain, and stress equals force over area, and strain equals delta over L, or elongation over L. That's where this comes from. This is why we don't consider the initial piece of the curve, is because such a piece may have some, I'm going to ignore that there, because as we apply the load, now in the machine, there's a machine called a universal test rate, no, yours is not a Zwick, is it? Your machine,
We're going to use universal testing. What did you ask me for?
is your machine a Zwick?
I think yes. I think it's a Zwick.
I know our one is. I know ours is a Zwick down at Seven Hills, but I don't know what yours is. But it's essentially a universal test rig. It's exactly the same as the one we've got. However, we're going to be putting on tiny amounts of load. The Zwick, the machine that they've got downstairs, is about 150 kilonewtons on. It can do massive loads. So this is a tiny amount. And as our sample is getting the small load being applied, that first part there'll be settlement. If I don't cut that surface perfect, and my point that comes down on it is not perfect, there'll be settlement. So that's what we're seeing to the start. We're going to ignore that first 10%. We're going to ignore the latter part of it as well, because that's in the, what range would that be in? We'll discuss that in data week 1. Or week 2, sorry. Thank you. Plastic, yeah. We're only interested in this range there because of it's in the elastic range. That's what we're interested in. And we're assuming there's a straight line effect. Right. This is where we can identify if the 10% and 40% is correct. We're assuming that data should be a straight line between those 2 points. It won't be a perfect, but it should be good enough. We will have to test it, because if it's not good enough, what we're going to have to do, we're going to have to change where these 2 points come. We'll have to move it either further away from that curve, or move it away from that curve there, and we'll have to bring them in, potentially. The data will have to be within 1%. So what we'll do is we will graph live data versus a fit for equation. The R squared, you know what R squared is in Microsoft Excel? If you don't, you will next week, because I'll be teaching it to you in the tutorial. We'll do an R squared fit to make sure it's within 1%, i.e. 0.99 R squared. If it's not as good as that, then you'll have to change these 2 points to make it within that tolerance, and only then will your numbers be valid. Okay. Hence why it's an approximation of 10 and 40%. Okay. Hence why it's an approximation. But so the key thing is the quality of that fit. So I think what we'll do is I will literally do a demo just now. Not of the written report, but just of the Excel of how I would do it. I'm going to do it from memory. I've not rehearsed it, so if I get it wrong, please be nice to me. There's some YouTube videos. I would probably forget those. I'll just come to the tutorial next week. Take part in the tutorial next week. So let's do a live demo just now. And if anyone wants to have a look at my piece of timber from last year, have a look, pass it around if you want. There's it's not mine, it's actually Stefan's microscope image of the cells. So there's my straws essentially. There's a lovely video somewhere of a little girl with a piece of wood, very dry wood, and she's dipped one end into soapy water and she's blowing through it, and you have to blow really hard. I've never managed it yet. I've never had wood good enough for me to be strong enough to blow into, but there's a video somewhere of someone blowing through, creating bubbles out of the end of wood. I don't know how they've done it, but it is possible. So let's get some data for us to play with. One from 2 years ago. Trying one, well, I know it was trying one. Yeah, of course I'll take a 5-minute break. That'll give me a chance to find the data and maybe even rehearse what I'm going to do as well in my live demo. I'm going to regret this now. This is going to make a mistake of it, and people will be laughing at me. Essentially, what you're going to give is something like that out of your machine. Yeah.
一周有2天不能睡懒觉。
Should be 20.
Right.
I've never had 20 yet ever.
Okay. But
So
maximum will be 20.
maximum will be 20, but there won't be 20. I won't make people ask you questions. I promise. I won't do that. Well, I'll get them to ask you about the machine.
Okay.
Now, when you read through this document, I'm handy for you to be honest, because the test procedure, you need to follow it precisely. And if you want, I could get a Voltec. I could get Voltec. Come and give us a hand. Josh, what page is it? 25?
Yeah, sorry. The parallel one.
Yeah.
Sorry.
Thank you. Well, that's bending. No, that's alright.
But 20 then.
Yeah. So page 21. So you also have to determine what the test rate of the machine is. So I'll tell you in here, the rate should be determined from the result of a preliminary test. So we'll make up some extra samples and test one ourselves. Yeah, I can't do it today, unfortunately. Probably
finalize with what we're going to do. Are we going to do 6 sycamore ones, or are we going to do...
I need to get some wood first of all.
Oh,
We'll have a look today, see what wood you've got downstairs.
alright.
Because it might be what you've got rather than what I've got. I need to tuck myself in, sorry about that. Because I know I'm teaching on Thursday, let's have a look when I'm teaching. Oh, no.
Time today to come down.
Well, I can come down for 5 minutes, but I can't come down for long today because I'm teaching at Edinburgh Uni.
Okay.
I'm doing a spot
So
there.
maybe Thursday. as you said.
Yeah. We have a chat with Alistair Mead. I'll pick it out when what he wants me to do. Only he wants me to do stuff as well. I'll come down and let you know.
It's going to be from 4 o'clock to what time do you think?
I'll tell you that this week. It's
500多公里，
right.
开车去贵州玩。
We are 12 o'clock. And we're going to put for 1.5 hours. It's not going to take 1.5 hours. You'll be lucky if it takes half an hour. You'll be lucky. You're going to take long.
10个小时。
I'm definitely going to do this. We should make up some samples. We should break one ourselves beforehand. You know, nothing's going to happen. That sycamore piece did not behave as I expected it to behave. This didn't do that. This just went on. It had hard one. Even had an element of hard one. Up. It's the hardwood.
是要休息了，也是要去
I think what we might do is we might just stick to softwood. So we've got lots of softwood.
太累了。
But what I'm saying is though, is how we set up the machine.
我上次从广州开回来都觉得很累。
Yeah. Well, anyway, that looks like that's for you, Claire. And I'll get myself ready.
才去爱丁堡。他不理性。福州。 28天，28小时。
路线的。
做轮渡的，在尼地海峡做轮渡过去。
它是高德地图是吧？
好像是申报什么的，然后就那个拿那个车牌就可以直接开。走。
看农业公。
有路线，看一个怎么走。
船，
从这边去，阿姆斯特丹。
去10000公里，一年才开这么多，我们一趟开这么多，28个小时，
28小时是多少天？
不到10天，反正。 对
5天。
6天吧，6、7天吧，一个星期吧，开一个星期。
傻逼，我操！萨特斯坦，方都开到中东了，我操！
中凯农业工程学云校区。
Yeah. So I know that not everyone's back just now. Let me talk you through this very quickly. I think what we'll do is I'll give you a quick demo of what we're talking about today, but I'll give you the full thing on next week. Because there's techniques I'm using in here, which I'm not going to have time to explain today. Let me rephrase that, sorry. I'll show you most of what you need today, but not all of it. I'll show you the rest next week. We've got lots of time on this. I'll show you enough to get started. So at least next week you'll know what it is we're trying to do. It's even the same data set. What's that? That is. It's good, that's the same data set.去吧。
说那个羊肉太骚了，
Okay, well, no, we will.
那口料酒的。
Right, is that all? Perfect. Right, okay, I'll just go through this just now, but I'm going to go through it again next week and we'll do it from scratch next week. Okay? This is obviously not your data. Or yours will look slightly different. This is from 2 years ago, and in fact this one here isn't. This will be from 3 years ago, because I would have demoed that to them. Not too sure, it doesn't matter. But yours might be different, graph-wise. So what you're going to get is actually this. You're going to get it's not blank, sorry. You're going to get, no, let's be fair about this. What you're going to actually get, you will get 3 comma delimited files. They're not even going to be Excel files. And this is what the ZWIC puts out. It puts out a comma delimited file, which we can import into Microsoft Excel. It's just that I've been very nice to the students last time, and I've then imported all 3 samples into one spreadsheet. I'm not going to be nice to you. I think you're better than that. What you're going to do is you're going to start off with taking the 3 comma delimited files and bring it in to at least this starting point. So that's the first step you'll have to do. So that's essentially what we've got here. Now, you'll see that on sample 3 and sample 1, I've not deleted anything. You've got some numbers up here. My personal opinion, let's get shot of that, let's get rid of it. There's some information in there that you might need. Well, I've got the rate. The rate is the rate of the head movement. We'll only be using the head. We will not be putting any transducers or LVTs. They're not actually called LVTs, but we all call them LVTs. But we know what we're talking about. We won't be using any of those because the samples are too small. So we'll only be taking the data from the head as the head moves down. The head will physically move, and as it moves, it's recording the resistance. That's all that it's actually doing. So it's recording the movement and the force. That's what it's doing. And as the head moves down and then the force then reduces, that then means this is broken and it's no longer resisting the force that it once resisted. That's all that it means. It's nothing more complicated than that. When you come down to 7 Hills, you will see a slightly different setup. You will see we've got a new 4-point bending test rig. It's brand new. It's just been commissioned. We'll probably demo that. And what you'll see there is you'll see an awful lot more things happening with more data being captured. but in essence it's the same thing. Right. So in sample number 2, oh sorry, I apologise. First thing I'm going to do for my sanity, because I like graphs a certain way, I'm going to convert everything from a minus to a positive and positive to a minus, because I want my graph to be sensible. So just go with me on this. So here, minus extension. I'll go x. I'll go I'll just keep. Why is my mouse being weird? Just do that. So all I've done is I put minus sign. Do it again. Equals minus that. Copy that, paste that, then bring that down as you done last week. Do it all the way down. Whilst I'm doing this, I'll notice how big my file actually is, and I'll record 1838. 1838 is that there. I'll just remember it, or I'll record it. You can see all that I've really done is I've just changed the sign from negative to positive. That's all I've done. Just select all of that. There, and I go, oh, I won't do that, I won't do that. I'll do something slightly different. Remember last week? I say last week, what I mean was, for those that were with me last week on the tutorial session, I'll go insert, scatter. This time I'm going to do just the points. Will I? No, I won't. I'll do this one here. Scatter with straight lines. I'll go select data. Add. I'll go live or samples. Sample 2. X. Now, what was it? 1838, wasn't it? 1838. And then my Y. So that is my sample number 2, and that's it graphed, okay? Nice and easy. And we can see we've got an F max around here somewhere. I could manually try and find it, or I could just be sensible and just do F max and just go max open, and then it's the load that I want. Oh, sorry. 8. There's my maximum load, and it's in newtons. So I'm starting to build up F max. Now what was that I wanted? I wanted F1 and F2. What did I do there? F1, F2 was... What I want you to start doing is doing what we've done on... Who was there? Who was not there on Thursday, first of all? Sorry, last Monday at Excel. Who wasn't there? Right. Were you there, yeah? You weren't? Okay. I would suggest you do, I've left the notes online. Please work through it before next week. Don't come next Monday having not looked through the notes, at least even for 2 minutes, just before the class even. Just please have a look through. So what I'll do is, just to save a bit of time and get everyone to go home, I'll have a look at a more complete example of this. The same data set. So far, I've done exactly the same thing. Jumping around. Oh, what's wrong? Mentioned it or something. Right. So F max, just max. And that's just 10%. So all it is going in there and taking that multiplied by 0.1. This one here is multiplied by 0.4. Then I've got my breadth and my height, even though they should be exactly the same. It doesn't overly matter if they're not precisely the same, but the area is important, so you need to record them. Because it's a force like this. So the breadth, and it's the average. So when we're measuring these, where's my calipers? My calipers are not working just now, but we do have professional ones, and much better quality ones down in the lab. If we want, I'll bring my other ones. We want to measure this 3 times. Once at the end, once in the middle, and once at the end. We record that. Same. We record it and we get the average for each, average for breadth, average for height, and for the overall length. Usually just measure that just the once, because we're not really going to get much of a tolerance between there, and there. Measure that just usually once for a small thing like this. So the average value now, I've not put the correct numbers in here. I just put some numbers in, 25mm by 150mm. That's what I've done here. What you'll notice though, for those who were not there last Monday, please look at the board or you will miss it and you will regret it. We see here, I've named my cells. See the name up here? That cell, and for that cell, and these should be named as well. I notice that one's not, oh it is, that's also named. Perfect. Let's fix that. That's how it should be. Perfect. So we've got those. Now we need to find the row and the value. I'll not show you how to do this today, but I'll do it in more detail next week. But essentially, if we have that number there, we're trying to find that number. We want to, now that is just 10% of that. Our number of points that we have in our test machine might not have the resolution to find exactly that number. So we use this here. We use match that number there within that column. I'll go and find the row that number best matches that. It's done a best match, and then it's given us the actual number at that row. So the nearest point that we've got in the machine is actually that one there. So it's about 8 something kilonewtons out. Sorry, 8 kilonewtons out? No, 8 newtons out. That's what it is. 8 kilonewtons, be mental. And this one here is matching this. Far away, it's about 5 newtons out. But we want the actual number, not the calculated number, so we need that. And then from there, that's the vertical. We want the location on the horizontal as well. Remember that W1. So we then use this. We use an index. So we'll go through this in more detail next week. So we've now got our 2 points. Point F. Wrong with my PC. F1, F2. We've now got our 2 points. Okay. So what we do is we then take the data, and we're only going to just graph the data within F1 or W1, W2. That's the 10 and 40% that we presumed would be a good enough fit for a straight line. We then would do that using the 2 points we just got. And we just hide everything else. And then we do what's called an equation, fit. A fit. Or add trend line. So we add the trend line into that small amount of data that we've got here, between the 10 and 40%. Make sure that it's linear. Show the equation on the chart. There's the equation there, the straight line. And then the r squared value, r squared for a 2D surface, or a 2D plane. It's quality of fit or goodness of fit that we would call it. Remember we said it has to be within 1%. Has to be, and if it's not within 1%, then my W1, my W2 have to move, so we get that fit to be much better. What we find here, we'll look at my r squared value. And it's within 1%, so it's perfect. I don't need to change. However, chances are yours will. Chances are yours will change, because out of 3 samples, probably 1 will need to change. Okay? You just change it. You just move the point in a little bit, or yeah. Once we've done that, and that's just a check, it's purely just a check. We go back up here, and we can type in that equation, which is this equation here, F max divided by the area. Being long-winded here, that area there. Then, now that we've got the points for F1 and F2, W1, W2, it's really quite easy. Just add it all in. And you can see by naming of the cells, for those that missed it, please have a look over the material from last week for the Excel. It means your equations look a lot healthier to read, easier to understand. And that's it. That is your mathematics done for that coursework. And now it's a case of you just simply writing up your coursework. I will go over with you in the tutorial Excel session what that looks like, but it'll be, as I said a number of weeks back, on the back page of that document, Josh, not the back page, but page 32, I think it is. Page 32, yeah. The reason why I printed off one from a colleague here, but I thought, well, I'll print an extra one off, but I don't want one lying about in my office, it'll just gather dust, hence why I just gave one away. But essentially, page 32, you have got, I would do if I were you, I would literally do this, copy it to Microsoft Word, that's a mess. I'll tidy it up for you, I'll give you something to copy and paste if you want. I'll give you a format to copy, but it's essentially that, or tidy that up if you want. But that is your framework for your report. Okay? So if I ask you to report on the test sample, test piece, this is what I cannot answer for you today. We'll only be able to answer that for you next week. once we've selected the actual material, you'll have to ask us these questions. It'll be up to you to ask us. So if you're not there on the day and you're not there to ask, you'll have to ask one of your friends. Right. Let's encourage you to be there. You should be there. Let's call it compulsory by option. You know what I mean? Just be there. Okay. I think I've bored you long enough. It's pretty straightforward. We will go over how to write all this out in more detail later on. Right. Next week. So next week, class is normal, and it'll be then from 12 o'clock, it says 12 to half 1, it will not be, it will be probably half an hour. Is it the new machine or the old machine we're using?
We're going to use the new one, that's
Right.
my understanding.
Trust me, you'll be lucky for half an hour, because the old machine used to be work, not work, work, not work, and we spent most of our time trying to make the machine work. This will be probably half an hour, honestly, it'll be quick. And it's as simple, the setup is easy, you put it in, you put the load on it. You will have to do some measurements, so you will have to do some measurements for us with calipers and scales. Please read through the document to understand why I'm saying this. You'll have to record certain things. You'll measure it all, put it all on the whiteboard. You'll all take a photo with your phones. I'll do the same, I'll put it on Moodle as well. You'll record all of that data. We'll test the samples, and then after we've done that, we'll take the samples and we'll put them in a metal tray. We'll put them in an oven for 24 hours. Somebody will volunteer, I'm hoping. You got a class on a Tuesday? Perfect. So what time's your class start at?
2.
Afternoon.
Perfect. So one of you or two of you can come back down to meet my colleague. Go downstairs. I'd imagine in the morning you'll have taken them out, so that when they're handling them, they're not hot. Right? We'll take them out, and you'll take them out, I won't be there, and you'll then remeasure them. And more importantly, you'll re-weigh them. You'll weigh them again. And you'll need that for something. I've not told you what that is yet. If you've read that document, you'll know exactly what that's for, because you'll have to report on it. Okay? Yeah. You'll have to report on that thing that I'm talking about. Can anyone guess what I'm talking about? Why am I going to weigh it before we test, and then after we're going to weigh it again after it's been in the oven for 24 hours at 100 degrees Celsius? What would be the only difference in the weight?
Moisture loss.
What?
Moisture loss.
Moisture content, yeah? Perfect. So that's the moisture content. And within this document that you're looking at just now, it will tell you, it won't tell you how to calculate the moisture content, it will tell you where to go to yet another document, and it will tell you how to calculate it. It's super easy. In my lecture slides, I will show you how to do it as well, but I want you to find it yourself. So next week you can actually do the write-up. So please look through the document. Right, and then after that, 2 o'clock till 4 o'clock, we'll go back to E32 and we'll actually process. It won't be the data we'll be processing for this year, but we'll process data from a previous year so you get an understanding of how to do it. So when we then get the actual data 4 hours afterwards, you then know what you're doing and how to do it quite easy without any questions. Make sense? Perfect. Right, well that's us then. Any questions? Everyone happy?
The 2 till 4, is that likely to be the 2 hours, or is that likely to be shorter as well?
This one here,
Yeah.
that will probably take a bit of time.
Right.
We're going to actually process some data. We'll process not our data, but the previous year's data. And people will be asking questions and people will not have, it will take time. However, you can come in. There's also another thing as well, there's two exercises. One, the first exercise is how to find the intersect of two lines. I'll give you that. I'll put it on Moodle for you. You can sit and do that yourself first of all. So if you're also fast at Excel like some people are, you can do the first tutorial yourself. And the second one, you can, just what I showed you 5 minutes ago will be good enough for you. You can probably head after half an hour if you want. But other people might take the full 2 hours. All depends. Right, all good? Right. If anyone wants to have a chat with me privately today, Mondays will be my office hours this week. It's usually about this time for about an hour and a half. But today I'm a bit short for time. So. What I would say is just remember that your courseworks are only worth 30% all in. They're not a deal breaker.